5, 4, 3, 2, 1. Welcome to Horizon Royale in build mode. I'm super excited to show you around. Today I'm working on a very, really cool mechanic, and I'm excited to tell you a little bit about it, but I thought at the same time I'd show you a little bit of what we have going on here in build mode. You'll notice there's pretty much nothing here. Kind of crazy. We do have this respawn trigger here at the bottom, just in case people fall off the world or if they jump some way through the walls. But you can just take a quick peek around. I'm not going to say too much. If you haven't been to Horizon Royale, you can check this out to see how all these things work. But we have these kind of like player settings, computer menu thing over here. I'm working on a video actually for that. So that'll be coming out at some point. We've got the map selector, which needs to be redone. We've got this really cool stats board. Lots of cool stuff on here. And we got the guns, and you can see all the little parts to the guns and how those were made, and the little wristbands, and all the managers, and so many scripting parts, you know, like the hit point controllers and the hit point texts and all the things. So many things. And one of my favorite things is I built this debug switch, which prevents all of the world start events that control the world starting. So I can just, with a flip of a switch, stop that. And then lots of cool stuff out here. You can see you've got the grid, very cool grid that we've custom made. And then down here, I've got some these are all the scripts for the pistols. I used to keep the pistols stored down here, but I've actually moved them. So I actually should just go move this back to the location of the pistols. Now that the pistols are up here, we'll move that to there. And yeah, I mean, this is build mode. There's not much here, which is kind of crazy, but at the same time, there is kind of a ton going on. If you've ever been to Horizon Royale, it's got more lines of code in it than anything else I've worked on. One of the things I'm going to be working on at some point is reducing this. So we're going to have 100 of these. To have 100 maps, we need 100 of these, but because that in itself takes up 2% object capacity, the plan is actually to make one of these that spawns in and out each of the 100 and then adds it to its own list internally. It's going to be insane, but I'm going to probably keep making some really cool videos on how this was made, and definitely check out my personal channel, Lakes is Live. That's where I do like raw video content, and I've already posted some on like how we place items on this grid. So definitely consider checking that out and giving it a subscribe for some of my raw content, less polished than this. And so, yeah, I'm going to go ahead and tell you a little bit about what we're doing today. Because we spawn this map randomly every single time, this has a side effect where the spawn points, you can see them right here, are randomly placed. But unfortunately, random isn't random to most people. And so you get spawned in next to people all the time. What professional games do, and Wafflecopters happened to share this with me, in his game Zap Zap, which was one of my first favorite games in Horizon of all time. It's like so good. What he did is he actually was calculating what spawn point was the furthest away from people. And now while we could do that, I've actually got a similar idea, which is that we're going to calculate which random position has the fewest lines of sight to other players. The goal being that when a map spawns in, it might place you inside of a room because that room has less lines of sight to other players. So you might be asking how we're going to do that. Well, the first thing you need to know is we've got a respawn controller. This respawn controller is in charge of respawning players. So you can see it's got this kind of respawn point, which is those 4 guys there, send themselves to the respawn controller. We've also got this is the Raycast that fires to find locations. And so we could write this into the respawn controller, but that's not the best way to do this. And we're working on a new scripting ideology. So you can see this is at 76%. This is bad. This really should never be above 50%. And I honestly need to come through here and cut stuff out and move it into its own script. And so similarly, when I added hit points to the game, we actually created the hit point controller. And so the way this works is when the respawn controller receives that somebody's been damaged and it's a verified damage that counts, it then sends it to the hit point controller, which subtracts a point and then sends that event back. And that happens within like 2/60ths of a second or something ridiculously fast. It's really quick to communicate between these two. And so this is now just an comes in and then it comes out. So if you think of like a switchboard or something, it's like this one's wiring into here and then it's wiring back into here. And so this script is at 35%. And that's kind of actually crazy that it's so big, but it's doing a lot. So you can imagine all these scripts add up to a ton of capacity. Do note that that capacity amount does not count against your capacity meter. And it's just a number that is the limit of this object. And I'm not sure if this is allowed to be public knowledge, but I'm going to share it with you anyway because I think it's really interesting to know. The reason script gizmos have a percent capacity limit is because the size limit of a packet or something like that is the size limit. So what you're actually seeing here is a physical, like some length, or you can imagine an image could only be 1 megabyte big. It's like that sort of a limit. And so there's some limiting factor that prevents these from being above that. Maybe one day they'll increase it. I'm not sure if that limit still is a problem, but I know a couple years ago, that's what I heard at a one of those little dev things. And so interesting point there. That's what that capacity limit is, why it applies. So what we're going to do is build another one of these sort of in and out controllers, which will then determine the position we want to go to. So with that said, we're going to write the script and test it while we're in debug mode, and then we're going to come back and link it into here. And so the first thing we want to do is think about our script. So I'm going to go gizmos and pull out a script. Now this script gizmo needs to know a few things. It needs a raycast. And so the first question in my mind is, can we fire a raycast multiple times in a while loop? And so I'm just snapping this to here because that's what I like to do. And then I'm going to give this script a good name, which is going to be called find position control. And so the goal is that when you receive an event, which we're going to call find position, it's going to then determine a position for whatever it is or whoever it is that sends us. So the reason we're going to be doing it in this way, rather than knowing that it's always talking to that respond controller, is because there is an opportunity here to create I'm hesitant to share this idea because I don't know when it's going to get implemented, but it's going to be awesome. Basically, when one player is playing the game, we're going to spawn dummies around the map. And we want to use this exact same script to find the location that has the least lines of sight to the player. And then, which really doesn't apply. We just need to find a line of sight. And so the point is we're just going to send an event to this controller, which will find a position and then send back a position. So when world is started, when find position is received with new parameter, which is going to be an object. And this object is the receiver. So this is what's going to receive the value back. Before you accept after C. Receiver, confirm. And now that we have that object variable in here, we don't need when world is started. Now find position with a receiver, we just need to continue passing this object variable along until we are done. And so what we want to do, ideally in the perfect world, it would be 2 embedded while loops. So it'd be while there are less than, say, 20 positions to compare against, and then while that position is compared against every player in the world's position, then we're finding, and so it'd be like 2 while loops, but because 2 while loops is almost always guaranteed to break, especially, I've done this demonstration once before. I think it's kind of worth showing again if you haven't seen it. Think about your while loop in a standpoint of how many times does the thing have to happen? And so if we think about a traditional while loop that has to compare one time for, let's say, 3 players, well, there are 3 players. It compares against those 3 players. In this case, we want to compare, say, we're talking about doing 20 times. And so we'd have 20 of these. But then in each of those 20 times, we have to compare against all of the players. And this is where this starts to get crazy because you have to do 1 and then 2, and then you do 1 and then 2 and then 1 and then 2. And that is just for 3 of these options. When you add a whole nother set of 20, this chaos is what causes the while loop to break. And so it's like linear versus exponential. And if I've got the names wrong, please correct me in the comments. But basically, if you're in a linear state, it's usually pretty safe in a while loop. But if you're in an exponential, it's not. And because we're in an exponential, we need to do it in a different way. And I don't know that that's actually exponential. But the point is the end factor, whatever that means, is bad. And so we're going to create an event loop. And so we're just going to go ahead and give this the name loop. And I just use loop a lot. It's a great name for an event. It should be in here. There it is. So send loop is received with the object parameter, which we're just going to call R, which is going to represent the receiver still. And that's just a short way to not have to type the whole thing out and worry about me spelling it correctly again. And so when this find position is received, we're going to send loop to self. Problem is, what if loop is already running? So if loop is already running, we should have a queue. So let's go create a new object. And it's worth noting that this loop event should only take 1/3 of a second. So I'm expecting it to be very fast, but in the off chance that two people die within 1/3 of a second of each other, we should have a way to queue the people that we're comparing against. And so this will be the queue. And there's a queue of objects, but that has to run in parallel to a queue of players, so plids. So as I'm thinking about this, I'm realizing that and we're going to call this plids queue. So let's try that again, player list, plids queue. And then with these two things running in parallel, we know that the player that we're currently working with, we do not need to check the line of sight to that player. So that's not something we have to concern ourselves with, which is why we'll have the player ID coming through as well. So we're going to go grab here and go grab player and grab ID, which is called current or the TP plid. Now, the good news is when we do this for something that's not a player, when we need to get a position, but it's not a player position, we're only going to be checking to see if this player is in the list or not in the list. So theoretically, if it's a server player, they're not in the list, so it won't affect us. So when we send this event with like a server player and the object variable for our dummy spawner, it won't affect. So that should be safe. I'm going to go ahead and delete. I'm going to put one while loop down and delete this one. So the idea is we send loop to self, and then when loop is received, we just work with item 0 from this list. So loop is firing at 60 times per second. That's the fastest it can fire. When we send loop to self, it could cause a problem if we were sending parameters like this, but because we're going to be adding these to the list and we're going to add them to the end of the list in parallel. So there we go. We're going to go grab these two lists over here. We actually will not cause a problem because this event being sent again is just going to either start up a fresh loop or it's going to continue the current loop. And so once we have completed, there's a couple things we need to do in here. So we need an if. This while loop goes in here. I haven't got there yet. I already know what I'm doing, so I'm just like trying to sketch out the thoughts so it's easier, but I'll explain it as we get further along. So the first thing that we're thinking about is, remember how we talked about being a while loop inside of another while loop? Well, to do that inside of an event loop, you have to have an if and an else. The if statement is the first while loop running, and this else is when that while loop has completed. And so when that has completed, we need to do something else, which is remove the items from the list and say if length of list is greater than 0, we know that there's still items in the list, so we want to continue looping. So we're going to go grab length of list, put that onto the left side, and it doesn't matter which list we use, so we'll use the receiver list, and the queue list, my bad. And then with that, we'll just go grab the number 0 and drop that here. Now, with that said, in this if statement, we are constantly sending loop to self. So we just grab loop and put it in there. And then down here in this if statement, we are also putting it in here. And so we say send loop to self, and then if it's still greater than 0, send loop to self. And so the question we're tracking is twofold. So this if statement, what are we trying to accomplish? We're trying to accomplish a goal, which is to either find a position that has 0 lines of sight to other players, or it is the best option out of 20 choices. And so we're going to create a new vector list of possible positions. And so we're going to call this possible positions. There we go. So possible positions is a vector list. And then we're going to create a new vector called current position. And so current position will be the previous position calculated. And so possible positions, we want to be under a number variable that we're going to create. This is so we can adjust it later and just also have a label on it so we can easily read the script. And this number is telling us max checks. So max position check. So max position check. So this is the max number of positions that we'll check, which we are saying is going to be 20. I was thinking about doing 10 actually, because I feel like 10 is plenty. And so you could imagine if you as a player, just like imagine you're not the algorithm, but you're an actual player and you're provided 10 positions across the map. And you're like, which of those 10 positions would I choose? You will choose one that's the best. And out of 10 random positions, there's a pretty good chance that one of them is going to be the right choice out of all the others. And so our suspicion is that we don't need to run 20 because the improvement factor beyond 10 is probably not that great. What that is to say is that every time we run the code after the 10th time is less efficient than the times we ran it before. So think when you're comparing just two items, 0 and 1, there's a good chance that the third item could be better than both of those. The fourth item could be better than those three. But as you add more, the comparison against all of those becomes less and less likely that you're generating a random position that happens to have a better value. And so there's one additional thing that we want to check. So we've got current position, and then we want to know is this number is called current plids in sight. Okay, so current plids in sight is another number. And so if current plids in sight equals 0, and so what we should do, this is hard to do, but I think it'll work. Normally what we want to do is in this if statement and in this if statement, we set it to -1. So if on world start, it's at -1, this is okay. So I'm setting it to -1 by default. And then I think I've got a better idea on how we're going to keep this. Basically, it always needs to be -1 if it's not actually being set, because -1 is out of index because -1 isn't a real number. So real numbers are 0 plus, which is like how many it's an actual number you can count. You can't really count -1. It's not like there's an actual negative number of players, right? So, okay. Now, when the loop is received, we're comparing these two things and saying, if either of these things are true, we're going to stop. And so we're going to say, if this or this is not true. And the way that we do that is by using the not operator, right? So if it is not equal to 0, or it is not less than 20, I'm just trying to decide if I can put that inside of there. So this, I'm thinking I can do it the other way, right? So let me write it out and then see if the logic still works. So if I put the not there and the or here, and so it says if it equals 0, that means it's true, which causes this to stop running, because this has to be false for it to keep running. And then this one is true, that also causes it to stop running, which causes our else statement. And so this should work, yeah. And if they're both false, it's going to keep running, yeah. Okay, so then the things that we're checking is if the value equals 0, that's the goal, is that our plids in line of sight equals 0. That would be a perfect location. And if you're playing with only a few players, it's quite possible this happens well before we get to that max position check. And so then max position check says, is the length of this list, so we're gonna go grab, oh wait, we already have length of list here, don't we? So grab length of list, put that there, and then grab the possible positions list, drop that here, is less than the max position check. Then we're gonna do this thing. Okay, so we're gonna constantly loop, but I'm putting the loop at the end because I like to think chronologically, so that makes sense. We need to determine current plids in sight. We also need to clear this position list, and we need a parallel list. Well, no, we don't, because of a thing. Wait, no, yes, we do? No, we don't. Okay, so how do we do that? I'm just thinking in my head. You know how I said -1 is out of index? We're going to actually set this to be 13. I know this sounds crazy, but 13 is also out of index because, well, 12 would actually be out of index because it's the number of players. In fact, we're just going to set it to be a really large number. We're going to call it 100. It's just a nice, easy, round number. So the idea is that, brain, catch up. So the idea is that we need this number to be larger so that we are running this if statement inside of the while loop, right? It's inside of the while loop, I believe. No, it's not. Gonna need to walk through my head here. So I'm kind of jumping the gun because there's just so many pieces to this puzzle to have to solve, and there's like so much I'm trying not to forget. So the way this works is that the length, or excuse me, these possible positions are either placed either at the beginning or the end with this if statement. So this if happens at the end, which has an if and an else. And then there's either two ways to add to list. So if you look at your add to list options, there are two of them. You can either add to list or add an index. And so the first one will be that, and the second one will be that. And so you'll see that this one allows you to provide a number, and this one doesn't. If you don't provide it, this puts it at the end of the list. If you do provide an index, like say 0, it puts it at the very beginning of the list. And so if the value is better, we're actually going to swap these positions. So if the value is better, then we're adding it at index 0, which is that current position. You'll remember that we're going to be calculating. So we're going to go put add current position at index 0. Otherwise, add current position to this position at the very end. And so this is just keeping track of the number of positions we've checked, and we put the best one at index 0. So what we're checking, though, is this number. And so we say if this number called current plids in sight is, or actually, oh yeah, so we need two values. We need previous plids in sight and current plids in sight. So we need a new number called previous plids in sight, so we can actually check these. Previous plids in sight. Okay, so we've got if the, and I think this one has to be set to 100, whereas this one needs to be set to 0. I don't think this one actually matters. And so previously we were saying if current plids in sight equals 0, we actually should check if previous plids in sight equals 0. And so then what we're saying is, does the current plids in sight, is current plids in sight less than the previous plids in sight? And if it is, we want to then update the previous plids in sight to be current plids in sight. So we found a new contender to be the best item. So this guy is our new best item. So it's what we're checking against. So if it happens to be 0, then we found a winner. And then we're adding current position to index 0, and that's what's going to stop this, which is going to allow us to say, okay, let's use current position, which we'll get to in a second. So in the while loop, this is where we're going to determine the number of plids in sight. So that's a little bit of math we need to get to. And before we get there, though, we need to set current plids in sight to be 0 before we run the while loop. And then we are going to add 1 to index if there is, we'll get to that. There's a lot of math that needs to happen in here, and I don't think it's too hard, but we have a lot to do before we get to that. So what I wanted to finish off was this else statement at the bottom first. I'm sorry I'm jumping around a little bit here. It's just like trying to keep track of my thoughts. So maybe let's, we'll read through this at the end to kind of go from the top to the bottom when we're done. Okay, so then down here, when we're done, we're needing to remove item at index 0 from the list. So we're going to scroll down here and grab remove item at index from both lists, right here and here. And right before we remove item 0 from both lists, we actually need to go and grab the plids queued list. And then we need to send an event back. I'm not going to name this event yet. I'm just going to grab the values. So we're going to send the no event name to the item that is at index 0. So under our list functions, we can get item from list at index 0 in the queue. And we need to send it with the player ID in queue. And so this is determining where to send this player to. So the plid in queue is also going to be get item 0. And that's the plids in queue. Okay, so that will work. We do need to determine a name, and so that I don't forget, I'm going to add a comment, which is going to be determine event name. Okay, so we'll come back to that. So there's that reminder. We remove item zeros, then we check. And then the other thing that we need to do, this is kind of like ending this whole event loop, right? And so when this ends, we need to reset some values. So we're going to set our previous PLIDs in sight to 100, thus basically setting it to be reset. And we also need to clear our current list. So we're going to clear the current list of positions, which reminds me that we actually need to grab that position. So when we send player through, we also should grab get item 0 from the possible positions list, because you'll remember that we put the best position at index 0. And let's make sure that's true. So if it's 0, yep, that should be true. And then we'll get to the while loop in just a second. Dun, 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 dun. And then otherwise, if there is still items in the queue, we send loop back to self. So it just keeps going until it's finished going through all the current players. And then this next step is going to happen before everything else. So we need to know who is in the world. We're going to create a player list, which I usually just call PLIDs. And so I call this all PLIDs. Okay, so here is our all PLIDs list. And then we also need to know about our Raycast from before. So I'm going to create a object variable called Raycast. And if we are only able to fire the Raycast one time in a while loop, I don't think that's going to be a problem. But if it is where you can only use the Raycast one time during a while loop, the reason my concern is for that is because while loops happen instantaneously. And so it's a ton of things happening all inside of an event. And the way they work is a little bit different than you might expect. So for instance, if you had one while loop and then another while loop, this while loop runs at the same time as this while loop, which is unprecedented. So if you use like a variable in this while loop and in this while loop, they will both be sharing that variable and it causes all sorts of errors. So my concern with Raycast is if it's trying to use the Raycast at the exact same time for all of these things, does the Raycast work or does it only work one time per 60 seconds? Excuse me, 1/60th of a second. Because this is happening, what will happen is 12 times within a 60th of a second. So anyway, I'm just like not sure if it will allow it, but I think it will. We'll find out though in a minute. And so if it doesn't, we'll create a list of Raycasts and just have 12 Raycasts in a list and then use it once per player. Okay. So to create a list of all the player IDs, pretty easy. We're going to go up here, grab when player enters world. When player exits world, we're going to go grab some fancy if statements from here and there. And then we're going up into here where we're going to grab, does the list contain the item for world exit? And we're going to scroll to the top where we can grab the not operator and say, does the list not contain the item? The item is the player. The list is the all PLIDs list. And we'll duplicate that up to here. So now we're saying if it does not contain the player and if it does contain the player. And what do? We're going to add or remove if those things are true. So we'll grab add to list and then remove item from list. And we just drag player into item slot and then duplicate the list by thumbsticking to the right into both of the list slots. And like that, we have now tracked what players are online. Now with those players tracked, we are going to be able to see that in our while loop. So what we need to know in our while loop is the current player ID. I like to run while loops in a very interesting way. So I'm going to create a new list of players, which I'm going to call iPLIDs. How does this work? This is my favorite thing. I mean, I used to write really complex things to try and figure this out, but this is so straightforward. My brain just, it like clicks with this one. And so it's like previous to this, I was like, my brain was like, oh, I'm off always. I'm like making mistakes. But this idea is you set iPLIDs to be a copy of the all PLIDs list. And then what you say is while there are items in the iPLIDs list, we do the thing. And so we're going to go to the operators tab and then scroll to the top and grab, is the length greater than? And so then we'll go grab the length of list. We have one of those here. So we'll duplicate that here, drag iPLIDs into here. And we say, is the length of iPLIDs greater than 0? And then we go into our list functions and grab remove item at index 0. So remove item at index 0 from the list. And then we have created a while loop. This is what a while loop is. And so what it's going to do is for 6, or if we have 12 players in our world, we could support 16, but in our case, we're doing 12 because we think the volume is better because it's on global audio. So people can have better conversations with those 4 extra people. You start to get lots of overclash and it's just not as fun. So that's why we're doing 12. So for 12 players, it's going to say set iPlids to all plids. And if all 12 players are online, it's 12. And then while the length of iPlids is greater than 0, it's going to remove items one at a time. But what we're going to do right before this is the other remove item from list, which allows us to remove a specific item from the iPlids list, which is get item from the plids queue list that is at index 0. So we're removing item at index 0 from the plids queue list from iPlids. And so by doing that, we do not have the player that we're comparing against in this list. So if it was 12 before, now it's at 11, and then it's going to run this loop 11 times. And so we're going to get to this in just a moment, but what we need to do is calculate the position that we want to check, the current position. We haven't set it yet. And so right here at the beginning, let's grab a I'm thinking right before setting iPlids. The order doesn't really matter too much. Sometimes it does. In this case, not so much. It's just kind of like, how do I want my brain to think about it? So the current position is going to be from the bottom of your operators tab, you'll find Raycast, get Raycast data. Now we can get the Raycast data from here and say, get Raycast data from Raycast Gizmo. And what we're looking for is the hit point. So it says hit point. And so we first need to calculate a position, and we're going to then check that position. Now we've done this code in our respond controller. So the good news is we're going to be deleting that and moving it over to here. And so the way this works is we grab a Raycast with override. So under actions tab at the bottom, you'll find Raycast with overrides, which we'll put right above current position. This orientation does matter, by the way. So this one does need to happen before this. So we Raycast, and this is actually only true for the Raycast gizmo. There's very little, there are no gizmos that immediately have results. So with the Raycast gizmo, you can Raycast and immediately get data from that Raycast, which is just bizarre. And so that's why I'm a little concerned on how the while loop will work. Like maybe we need a separate Raycast to work in the while loop. We'll find out in a moment. So we're Raycasting from the Raycast with a origin position that we need to determine and a direction vector. Now, if you aren't familiar with direction vectors, I'm not going to get into it today. We've got lots of videos that kind of cover this in a few different ways, but what we need to know is that a direction facing downward is 0, -1, 0. So that's X, Y, Z. The Y is your up and down. So -1 means the direction is pointing down. And so we're going to go ahead and type in -1. So when we fire this Raycast, it's going to fire straight down at the ground. So when we open this up, we do not want to collide with players. We only want to collide with objects tagged. If we collided with both players and objects tagged, it will choose positions that are on top of players. Not ideal. So don't want to do that. The Raycast distance, my understanding is this is pretty efficient, even if it is at 2000, but because we don't need it to be more than 100 meters, I set it to 100. And my understanding is that does make your script and your world run a little bit more efficiently than having it set to 2000. Hence, I'm actually changing it. So we've got the Raycast set to 100. Raycast with Raycast. Now we need to determine the origin position. This is fairly easy to do, and it is going to be under your operators tab. There is a vector, which is new vector from X, Y, Z. And there it is. We'll drop that here. And so our up position, we're going to set to be a specific number, which will be 50. So this is going to fire from 50 meters up in the air, which is really high. And so we can quickly check that by just opening the properties panel of, say, this guy here. And attributes tab, you can see that this is at the position 22. So 50 is twice this height. And we built on the grid. So this is actually centered on the world and on the grid. And so, yeah, you can imagine twice this height is really high up. So firing 100 meters is like 4 times bigger than we need it to be, but that's okay. Better safe than sorry. We might build some map in the future that's like really tall, and we'll be safe if we do that. So the next thing we want to do is think about the position of the grid. Now, this is a custom designed grid. We use 2 text objects to make this with just like evenly spaced slashes and then stretch them, and it looks amazing. But with that said, this is the same number of tiles divided by 2 that's on the grid. So like this is 2 meters wide. So normally the grid would be 1 meter. So it'd be like that. Or let me get in close. So like that. And so, but it's, what I'm trying to say is it's 64 meters wide and 64 meters wide this way. So with an origin position at 0, 0, we know that it ranges from positive 32 to negative 32 in both axes. And that's really only true for our world because we built at 0, 0. In your world or whatever you might be working on, your values might be from 0 to 50 or from a different value. If you build way over here, this might be from like 55 to 25 or whatever the values are. And so definitely just kind of check the bounds that you want this to be. And so what we do on our script, there it is we type in a random number with decimals, which happens to be right here. Grab random number with decimals, dropping that into the X, and we just type in negative 30 and positive 30. And the reason I do, oops, undo. The reason I do a couple meters in is I do not want people spawning on the edge of the world and then accidentally falling off. So we are 2 meters in or 6 feet in from the edge, which I think is a little bit safer, especially because we also have little bounds on the edges. So this is nice. And then we just duplicate this into the Z value. And so we've determined a random position to fire the raycast from a downward direction. And once we've hit a position, we've gotten a hit point. Now that we've determined our set current position, we want this to be at the height. So this is going to hit the ground. We want this to be at the height of where the player's head will be. And so we're going to go to the top and grab the plus symbol and set current position to be current position plus a new vector value, which is going to be 0, 1.50. So I'm estimating about where I imagine the player's head is. And so when we fire a raycast inside of this while loop, we're firing from where the line of sight of the player would be, not from the ground. So that's important. Okay, so we've determined the current position. We now need to figure out how many players can we see from this current position. So we've got a list of players to check against. And so what we have to do is then fire the raycast with overrides again. So I'm going to actually go ahead and duplicate this down into right here. So we're going to raycast with overrides, not from a new vector position. We're actually firing simply from that current position we calculated. So fancy enough, we just grab raycast and fire from the current position. The direction is what we're going to be changing this time. So rather than firing straight down, we need to fire at a player and see if we can see the player. And so what we're going to do is raycast with raycast from current position with a direction, and you can calculate, or you can create a direction pretty easily. We're going to do a normalized vector just on the safe side. I don't know if you need to make it normalized. What normalized does is it takes a length of any value and it makes it 1 meter. So if it's small, it makes it large. If it's larger, it makes it small. And so you can imagine if we grab random position on grid minus random position of player, that's going to be like 30 plus meters. And so normalizing it down to 1 meter is what we call a direction vector. And that's why I'm doing it, because this is asking for a direction, although I don't know that it's necessary. So further testing is needed. So anyway, to get that direction, as I mentioned, we need to take the current position and subtract the position of player at index 0. So we go down to player positions and grab position of player. And this is going to be the torso, or you know what, we're really looking for their head, right? So the head position of player that is at index 0. So we can just grab get item at index 0, thumbstick to the right into here. That's in not plids in queue. It's actually in the iPlids list. So make sure to replace that. Okay. So now that we've checked, we've fired this raycast at the player, we now need to find out, did it hit a player or did it hit an object? If it hits a player, we know that we have line of sight to the player. And so what we're going to do is go in and use an if statement. And so this if statement is just checking to see what did we hit. And so there is an option under the get raycast data, and it says did hit on raycast. Now this will be true for anything. And I just realized that we have it set to only hit objects, which is actually, I was thinking about out there. Oh wait, but that is important for our first firing. That's interesting. Okay, so we can do something slightly different. So I was planning to say if did hit player, because you'll notice there is did hit object and did hit player. we'll do the inverse of what I was thinking, which is if did hit object, we know that this is a good line of sight. Else, so we're actually going to grab a separate if and catch this. If not did hit object, well, what if it's free though? Oh, this is hard. This is really hard. Oh, this is difficult. Oh my goodness. Okay, thinking. Well, let's just make a separate raycast. I was worried about using the same raycast anyway. Let's just make a separate raycast that's designed to hit objects and players. And so this one, 100 meters is still a good distance even on the grid. We'll do both players and objects. And now that we have that one set up, we're going to call this raycast while. So that way we can kind of define the difference between these. And this one is raycast position. So that kind of defines that a little bit. And then over here, we're going to create a new object variable, which we're going to call raycast both, right? Because the other one does just objects, so this one does raycast both. Okay, so then we'll grab raycast both, and we're going to drop it into here and into here, and I think raycast with raycast both from current position, and then what we're going to say is if did hit player, because the condition we're checking for is does it have line of sight to player, then we go and set the current plids in sight value to be +1. So then we'll go to the top and grab a plus value and say current plids in sight +1. Okie dokie. Okay, so current plids in sight +1. Now with that set up, the value here is going to go up, and I wanted to make sure that it was clearing up here. So set current plids in sight to 0. We've now set it to be +1, did get hit player, and then removing item 0. So at the very end, we can check the current plids in sight to the previous plids in sight. And we want to make sure that the current plids in sight is less than previous plids in sight. Question is, previous plids in sight, we didn't set to be 100 like we did the other one. Oh no, we did. Previous plids in sight is the one we set to 100. Sorry, I mixed the two up. Okay, so previous plids in sight starts as 100. So the first time this fires, it's going to be a number less than 12, like 11. Then we set previous plids in sight to be that new number. And then it comes through again, checking for a brand new position. And down here, we are adding that current position to the either at index 0 or to the end of the list, depending on how good the position is. And there we go. I think that's the script. I feel like I'm missing something really obvious. So I'm just kind of double checking everything here. So this while loop is going to run up to 11 times to get the number of players that it can. Then we send the loop at the very end so that it can go through and do a new position. We compare up to 10 positions. And then if it's ever 0, we just stop early. And we set current plids in sight to be 0. Previous plids in sight doesn't get updated until it comes in here. And it starts at 100, so it's not equal to 0. And then at the very end, we set previous plids in sight back to 100. And then we keep looping. I think this will work. This is a lot of scripting. So if you're following along, I know I said this in yesterday's video, but the same thing holds true here, which is if you are going to build a script like this, it's often wise to be testing it throughout and not just at the end like I'm about to. I'm pretty confident, but at the same time, it's very, it's a lot of anxiety just to be like, have to test it now. So I got to figure out a design for this test that makes sense. Okay, so problem is, let's think about this from the standpoint of there only being one player in the list. Like, let's think if there's only one player in the world and they walk through the trigger, there's only one player online. When find position is received, it's going to add that player and the receiver to the list, sends loop to self, previous plids in sight equals 100, length of, oh wait, I said I was going to talk to this through. This is a great opportunity to do that. Let's start from the top. Okay, so lots of variables. We'll talk about those. When world is started, we're adding the player to the list as long as they're not in the list. This is just a security check to make sure we don't add more than one player to the list, just in case this happens more than one time somehow. When world is exited, we remove from the list, and we only remove if they are in the list. Otherwise, it throws an error and says, items not in the list cannot remove. So this is just another way to check and make sure our script is safe. So then we're keeping that list up to date with the current players who are on the line. We then have when find position is received. So this is coming from any object that wants to find a position. We can then say what's the receiving object that we're sending this event back to, and what is the TP player ID. We then add the receiver and the TP player ID to a queue, and we send loop to self. So if there's already someone in queue, they're at the end of the queue. Otherwise, they're at the front of the queue. Then when loop is received, it says if not previous PLIDs in sight equals 0, or the length of possible positions is less than position check. So basically saying if both of these things are not true, we are then going to set current PLIDs in sight to 0, Raycast finding a new position on the map, setting that current hit point to be this current position, setting the current position to be plus 1.5 meters, so it's at eye line, setting iPLIDs to all PLIDs, so we have a copy of that list. So that way we then remove the current player ID from the iPLIDs list, and then while the length of iPLIDs is greater than 0, which if we're thinking about this from the one player standpoint, okay, so if you're seeing this video, it's an absolute miracle. I have been working on this for, if you're watching this, it's been a while. And I didn't stop the recording, and so the video stopped recording, and I'm only like a few steps from the end. So anyway, the last thing we need to do where I'd left off was that when we receive this event, new safe position, we actually need to delay for people who do not have fade on. Now, if you're not aware, we have a bunch of player settings, and one of those player settings allows the players to turn their fade off or on. And so when you teleport, there's that fade to black, and it slows down your teleport speed. So if you want to be in the game really fast paced, turning it off makes it instantaneous. And so for the people who are instantaneous, it's easy, but for everybody else, which is the default as everybody else, we need to have a delayed event, which will then respawn the player. So we're going to say when event is received, and when event TP, we'll create a new event called TP, and I've got an idea for this TP event, and the way that it's going to work, theoretically this will work. There's an object, and we have, this is called the respawn point. I'm going to actually write this all out. Respawn point. Well, anyway, if you're just joining us, I just spent, I don't know, like half an hour trying to get the darned computer to connect and see if I could even find the file, and I can't find the file, and it's stressful. It's really, really stressful. So I'm just pretty confident this video is not going to make it, but just in case it does, we'll finish it out strong. So now we need to know the player ID that we're teleporting. And so with the respawn point, the player ID, and the position that we're going to, vector called position, we can now create an event that says, very simply, if the respawn point is within, I don't know, like a meter of the destination position, or maybe 2 meters just to be on the safe side, we then will respawn the player, else we just keep sending the event until the respawn point gets there. And so we're going to say if the distance 2, so under our operators, scrolling down to vector, you'll find distance 2, which allows us to check the distance of the respawn point to the position value. So then we'll go and grab position of object, grabbing that, putting this into here, and then we'll add an else statement. We'll say, okay, so if this is true, we then go into actions and grab respawn, or excuse me, motion, grab respawn player to the respawn point, and this is the player that we're spawning. Now, if this is not true, then we're going to send an event to self, which is the same TP event. And so this TP, let's see if I can find it, send TP, there's so many events, send TP to self with the exact same lineup and the exact same orientation with player ID and position. But because we don't want this to get stuck in an infinite loop, we're also going to simultaneously make sure to move the respawn point. So just in case it hasn't moved to that position yet, we will move it to the position, and then eventually it'll reach that position, even if worst case scenario, there are multiple of these going with both respawn points. One of them will make it, then the other one will make it, and then they'll stop. And at that which point, then it'll respawn the player. Otherwise, it'll just keep moving until it gets to that position. And then we need to send this event up here in the new safe position. So now with that, we can link in, this is the player ID, that's the position. Look at nicely. The respawn point is what we need to do, which we actually determine up in this other event. So it's time to figure out what parts of this code get moved down, which is right here, if TP fades. We're going to drag this down into new safe position. And we need to grab that else from above. That's, I think it's this whole one here. So it says if TP fade, else, and then drag that into here. Okay, so we have whether or not they're fading and whether or not they're not fading. And then up here, we were doing a raycast and then determining if we hit the ground and then teleporting players around as necessary. So we're going to delete this because this is all happening in that other event now. So we can actually delete this. So when triggers entered by player, we send find position to position finder. We'll actually do this last so that it kind of lines up better. So it'll say, okay, so when triggers entered by player, set player gravity to gravity, send new gravity to self. If not current players contains player, add player to current player list, send find position to the position finder with self and the player. And then when the new safe position is received with the player in the new position, we can then actually act the rest of this, which is to fade, get the player's fade value. And if it equals 1, we know that they do not have fade turned on. And then we're going to check the player's sky value. So we'll just drag that in here. And if the player's spawn sky value equals 1, the ground, we're setting ground to be higher. So we're going to make them spawn in the sky. So we set the ground to be position plus a random vector between 0 and then the y value is what we're adding to and 0. And then we move the player to that ground position that we calculated. And if they're not sky, we just move them to position. So let's actually set ground right here and set ground to position right there. In fact, we can do that right here at the beginning. And then here, instead of setting ground, we can just do set ground to ground plus, just like it was before, and then move player to the position, which is either the position or the ground plus height based off of the spawn sky. Now, this is where things get complicated because we now need to spawn the player. So we're going to grab player ID again into all these places. Okay, so we're going to, if user position variable fade, okay, down here we're saying, okay, so they're not fading, which means they are fading. So if they're not fading, they are fading. And then if get user position variable spawn sky equals 0, we are getting a random item from the list is what we were doing. Now, ideally, we should actually cycle this current item. So instead of getting a random item from the list, we actually want to move through the list one at a time. So say, for instance, we currently have 4 objects out there. We'll actually go in and, see what we were doing in the past is we were choosing 2 of the spawn points were in the sky and one of them wasn't. And so we're going to actually rewrite this code. So 2 were always in the sky and 2 were, anyway, it was a bunch of really fancy math to make this work. But what we're going to do instead is actually cycle through the list of 4 spawn points, which is perfect. And so the way we do that is we grab the modulus symbol and we're going to grab the +1 value. So we're going to get item at index. And so what we do is grab the index of the current item. So the current spawn object in the spawn objects list. And if this index is -1, so it's the first time this happens, -1 gets turned to 0 because we're adding 1 to it. So let's grab a 1 and drop that in here. And then modulus means when we get to the end of the list, it goes back to 0 and it cycles back to the beginning. So we'll grab length of list so that when it gets to the length of list, it cycles back. And this is the length of the spawn objects. So we're grabbing 1 object at a time. Now, this is true no matter what we're doing, whether we're spawning in the sky or not. We want to set current spawned object to be the next item in the list. So get item current spawned objects and in spawn objects +1 modulus length of list. Okay, so we cycle through that. And then if get user persistent variable spawn sky equals 0, we know that they are spawning on the ground. So we respawn the player to current spawn object. Now this used to work, but now we need to send that event that we determined, the send TP. So we don't need to put the respawn here, but what we do need to do is move the current spawn object to the ground position, else we don't need to use this anymore, so delete that. We want to respawn the player. We don't need to respawn player ID. We're going to do that in the other event. Okay. And so we're going to move the current spawn object to ground plus this random amount, except what we're actually going to do is do that same before where we set ground to be +1. So down here, we're going to set ground to be plus this amount. And then we can actually move this down into here. And so this is the last step. And we only send TP in this else statement, right? Yeah, so only in this else statement do we send TP. And we send that with the current spawn object is what goes here. We send that with the player ID and not position, but actually ground, because we've calculated ground to be either on the ground, which is position, or in the air. So then we move the current spawn object to that ground position, whether that is here or not. And so since we know it's either 0 or 1, we're actually going to change this to be a 1 value to optimize our script a little bit here, or clean it up rather. And so if spawn in the sky is true, meaning it's 1, we are then going to set the ground to be up in the sky, and then we move that to player to the ground. We notice that we have also set ground up here, so that will work for both. Okay, so then TP comes through and it teleports the player once that spawn object has gotten there. We could even add like a half-second delay if there's any issues with this, but we'll find out in a moment. So I think we're ready to test the script out, which is kind of exciting. I'm very nervous, but kind of exciting. So script, clear, and play. Now you'll remember we're in debug mode, so nothing runs except that. I'm also noticing there's been people here for a while. There were 6 just a minute ago, and I'm like, oh my gosh, I want to play, but I also am supposed to be going to make dinner here like 50 minutes ago, but this, like I said, I got stuck for 30 minutes trying to fix that. Okay, so difficulty easy, wristband is on right, band size default. By the way, band size can be adjusted to sweater. Oh, it doesn't work in build mode, I forgot. It only works in publish. So weird. Wish we had parity. Spawn in, let's do spawn on ground. Fade on respawn off. We're gonna just do my default settings so I can kind of test that first. And then KO pop-ups on, yeah, that's fine. Okay, so when I walk through here, this is running the new code. I'm so nervous. I'm so nervous. Oh, it didn't do anything. Oh, didn't do anything. Oh no, it didn't do anything. Okay, so let's go find out why that didn't work. Which meant this list is 0, which is bad, but that might be okay. So then find position is received. And so debug prints that the length of both of these are at 1, which is why it went off twice, should be getting 0. So my query is, will this run if I publish the world and don't test it any further? Because build mode be like that, as you can tell. And the length of list isn't working. What is a workaround if the length of list isn't correct? Okay, I've got a couple ideas. Let's get through this. By the way, build mode is super laggy with asset spawning. This is true. This or this is not true. Oh my gosh, I'm so stupid. Oh my gosh, I'm so stupid. This is, if somebody caught this, props to you. I definitely didn't see this. This is backwards. This is supposed to say greater than or equal to. If the length, oh my gosh, so it wasn't doing what I thought it was doing the entire time. So the, okay, this will work now. Okay, let's go get. And this is why you test throughout your process so you don't have that problem. Oh, look at that. It worked perfectly. Okay, so I'm going to go teleport back. Let's go try the fading option. Oh my goodness gracious. I can't believe we're finally done. Spawn on ground. Let's do spawn in air first and just see how that works. Spawning in air totally works. Okay. Now we'll go do the fade on respawn for both of those options. Player settings, fade on respawn on. Spawn in air. Let's see if this works. Takes a second longer, but you do respawn. Okay. Let's try it one more time with the fade on respawn. definitely takes a second. Oh, where am I spawning? Okay, let's try to cap. This is the left side. Okay, this is the middle, maybe left side. Let's try it again. And back right. Okay, I'm feeling pretty good about this. I mean, that's pretty fast. This took a while the first time, but that is working. Okay, so fade on respawn seems to work really well. And oh, I'm so excited. This is such a big deal. Fade on, respawn off. Oh wait, no, I wanted to leave fade on, respawn. Excuse me, fade on, respawn on, but the spawn and air on ground. Okay. Okay, and nice. That was pretty close to ground. It was a little off the ground, but like not in a bad way. Okay. Fan-freaking-tastic. Oh my gosh, we did it. Okay, let's publish this, invite some peeps, make sure it works, and then hopefully I'll find that file so you guys can see the full tutorial at the beginning. And if you are watching this with the full tutorial, I am so blessed that we figured it out. And if you're not, I think we did show quite a bit in here that this is still worth uploading to the Lakes' Live channel raw. So anyway, either way, thank you so much for watching. Let's go test this out. This is the fun part. So let's go flip that debug switch to true. Go hit the publish button. Huge thank you to Oculus, Billy, Mama Bree, and everybody else who's been out tonight helping the world. Really appreciate it. 54 is still accurate since we haven't really made any changes. Hitting that publish button. And yeah, so we're at version 0.54, which means we're about halfway done. And I really feel like we really are at halfway. This is, I know it seems crazy, but like this whole thing needs to be redesigned. This needs a refactor. This needs a refactor. That needs a refactor. I'd say over half of the remaining changes are non-visible to the public. So I definitely encourage you to come in and try this out because for the most part, it is the game that we wanted to create, right? Like now we've got the respawn points in places that it's not going to feel like you're constantly getting KO'd, which is just massive. I'm only going to play 2 rounds because I really have to go make dinner for the family. I feel so bad. I'm trying to do better at being this, like, I don't know, a better family person. It's very hard. Y'all probably aware of that, but it's pretty hard. So I'm going to go enjoy some dinner with the family. Then I'll be back on later tonight to continue working on some of the bugs and things. And, yeah. Oh, man. I'm so excited. I didn't think I'd have this done for like another week. This has definitely been something that's been on my mind for a long time. And we had a lady enter the other day and she was just constantly dying. She's like, why am I spawning in the middle of everybody? And I'm just like, it's random numbers. I'm sorry. I'll get to it eventually. And so I'm so glad to get this done. Okay. So let's get over. I think people are, oh, they've left bubble wrap. Maybe they'll join if I send them an invite. Although, I don't know. Maybe. We'll see. I'm kind of excited. I'm also nervous because there could still be a bug, right? Like this is where we add more players in, we encounter more edge cases. And if you're not familiar with this idea of edge cases, it's that as you build more and more complex systems, there are loads of tests that you can't necessarily perform. Like you saw me test 4 different scenarios, like spawning in air, spawning on ground, spawning with fade on, and spawning with fade off. That creates 4 different scenarios. But there's many, many more scenarios depending on which of the settings, right? Like over here, when we go to the settings, we have tons of variety. Like this one obviously shouldn't affect it, like band size. You can make your band size bigger. Remember that wasn't working, it was spawning an error. I love that this actually works. Basically, what it says is in build mode, it says you can't scale text objects, but in publish mode, you can. And so by scaling the text object, you get this really cool band. We call it sweater size because Billy's sweater covers it up, so we made it bigger for him. Spawning on ground, fade on respawn off, YB button still respawn, KO pop-ups on, and I'm going to play in difficulty easy. Look at these difficulty settings, medium, hard, 1 HP. And so yeah, we found some like difficulty settings were causing errors that we just didn't expect, so only certain players were experiencing it. It's just kind of crazy because you can't really predict all of the things. So I'm going to go send out some invites to some of our regular players. Yo, up to! Invite to world.
Drift Queen.